Hi, this is Seung, and I'm the Principal and Director of Sky Academy, and I want to now spend this episode wrapping up the whole topic of indices and logarithms. So if you've been patient and put in the time and effort investing in your knowledge in relation to this topic, indices and logs, I want to now reward you by summing everything up. Okay, so first of all, we looked at indices. And when we looked at indices, what we realized was that there's a whole bunch of laws governing index form, okay? Indices meaning powers, right? And so we looked at the index laws, and we also looked at the two index identities. So in other words, the exponential identities. Exponential and indices, they basically mean the same thing. So which is a to the power of 0 is equal to 1, and a to the power of 1 is equal to a. Alright? And then, after we looked at the index form, we then looked at a new way of expressing index equations or index expressions. And that was, we can change the index form into what we call the logarithmic form, right? And the logarithmic form, remember, was just a way of expressing things so that we can now work with unknown powers, right? So logarithms was a way of working with unknown powers, and basically where the index form was y is equal to a to the power of x, where a is your base, x is your index, and y is your exponential result, we can rearrange everything, right, and still have the same expression in logarithmic form. And basically what you have is the index expressed in terms of the base and the exponential result in logarithmic form. So if you've got an unknown power, you use the logarithmic form to work it out. Okay, so these two are expressions of the same thing. Okay, and what we also did was we looked at the log laws, the laws governing logarithms, and we got to see that the log laws mirror the index laws. So for example, the sum of two logs is the same as the log of the powers, just as we realized that when you add two powers to a power of a common base, it's the same as multiplying those two exponential results. Okay, so see how there's a mirror image correlation, right? And we notice that mirror image correlation throughout all the log laws, and even to the two log identities. So the log a of 1 is equal to 0, and log a of a is equal to 1, just like in the index laws, a to the power of 0 is equal to 1, and a to the power of 1 is equal to a, right? And so we saw this mirror image correlation, right? And when it came to graphing them, we noticed, lo and behold, they do both. The graph of index of an exponential graph or an index graph will also have a mirror image correlation to the log graph equivalent, okay? And so what we realized is that, yeah, they are mirror images of each other about the line y equals to x. So in other words, if you fold this over onto itself, you will see that they're mirror images of one another, okay? And we got to see that what that is called is inverse functions, all right? The exponential form y is equal to a to the power of x, and the logarithmic form y is equal to log a to the power of x are actually inverse functions of one another. In other words, they're reflections about y equals to x. So in other words, what that means is that one curve is the same as the other curve, except that you're swapping the x's and y's around. That's what the mirror image represents, okay? So that, I suppose, is like a summary, a nutshell summary of what logs and exponential or log and exponentials is all about. Exponentials being indices, right? So indices and logs is all about. In future chapters, in a couple of chapters' time, right, in the HSC course, as opposed to the preliminary course, we will look at, in particular, logs, logarithmic functions, and exponential functions or index functions, right? And we will apply a topic called calculus, right? Which is, we haven't done that yet, but we will do calculus, but we will apply calculus to exponential and logarithmic functions in a brand new topic or a brand new chapter called exponential and logarithmic functions, right? So look forward to that. We will be doing that in future episodes, but in the meantime, I want to thank you for watching. I hope you were able to understand everything to do with exponentials and indices and logarithms. I'm going to stand to the side so you can take everything in that is written behind me. But again, like I said, I want to thank you for watching. Study hard. All right. Thank you.